Hello. In this video I want to talk about how to approach graphing y equals 3 cosecant quantity x plus pi over 4 quantity minus 2. Now, I do want to just remind you again about the basic shape of y equals cosecant x or theta. It really doesn't matter what we have here as the input, it's just a placeholder. But if there were an x here, it's not x as in horizontal motion, it's an angle. So just for really emphasizing that, I'm using theta. So because of the definition of cosecant theta, it's 1 over y, where it's the y coordinate at that angle position. And of course this is when the radius is just 1. You would want to find out where the asymptotes are. So you'd have to ask yourself, well, when can the y coordinate be 0? So of course we're talking about this. In this case, the y coordinate is the vertical movement, and so at 0, at pi, at 2 pi, and then going the other way at negative pi, negative 2 pi, and so on and so forth, you can see that the y coordinates are 0. So if you're going to evaluate cosecant at those angles, you're going to have an undefined or asymptote there. Okay, so it's basically asymptotes occur all multiples of pi. And then if you recall, the basic shape are like alternating u's, and what happens is at pi over 2 and 3 pi over 2 and multiples of pi over 2, it could be negative pi over 2, negative 3 pi over 2, and so on. Because you're talking about 1 over y, and the y is either 1 if it's at pi over 2 or negative 1 at 3 pi over 2, you get 1 and negative 1, so here's your lowest value in terms of the y movement like this when you're graphing this y equal to cosecant theta. And I just wanted to remind you why that is, because remember, cosecant of theta is 1 over y if you're on the unit circle, but if you're talking about any size circle, it's r over y. And when you look at the shape of the right triangle, the r is the hypotenuse or the radius of the circle, and then y or x, either one, of course that would be for secant, but for cosecant, when you're talking about y, this length cannot exceed the length of the radius. It's always going to be smaller except for at pi over 2 and 3 pi over 2. So that's why when you look at this ratio, r will always exceed or be equal to y. So you can't have true fractions. So in a sense you have sort of this dead space here. And then, if you're looking at this, these are alternating u's. You know, at pi over 2, you have 1. At 3 pi over 2, you have negative 1. And here's your asymptotes at multiples of pi. And you're fitting in your u's. And remember, these ride the sine function. And we can sort of dot that in if that makes it a little bit easier. So there's your basic shape. If we're looking specifically at y equals 3 cosecant x plus pi over 4 minus 2, you can see that here's your horizontal shift. It's shifted to the left. There's no change to the period because there's no coefficient in front of x. It's moved horizontally, vertically down 2. And there's a stretch from the axis of 3. So what I did is I went ahead and put your asymptote would be at negative pi over 4. And then your period is still 2 pi, where you have 1 u going this way, 1 u going that way. So negative pi over 4 plus pi would give me 3 pi over 4. Plus pi would give me 7 pi over 4. Okay. And essentially what I want to do is at pi over 4, you're basically mimicking what would happen here at pi over 2. And your value would be y equal to 1. However, what's happening is you would go over 1 from this axis, you'd go up, but you're really stretching it by 3, so it's going to go up 1, 2, 3. So you're actually going to be over here. So this is going to be the point pi over 4 and 1, and basically you'd have this kind of thing going on. Now I haven't yet, sorry, this isn't symmetric, I didn't draw it quite so well to scale, but basically here's your u. And then over here at 5 pi over 4, right, you'd start from your new axis here and you'd go down 1, but you're actually going to go down 3, like that. And There's your u. So there's 5 pi over 4. And this would be a total of negative 1, 2, 3, 4, 5. So negative 5. Okay. And that's really enough for being able to match this to something like a multiple choice or something like that. So that's plenty enough. But if you need to go further and you're like, well, no, I need to really know just how wide is this or how narrow are the u's. Well, that's when I go ahead and do what I choose anchor values for x. And for cosecant, I would choose pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6, right? All the multiples of pi over 6. Why? Because here you have the y value is a half. So when you're looking at cosecant, which is 1 over y, you're going to do 1 over half, which will give you 2. Again, that's for ease of computation. So for example, if I were to go ahead and solve for, okay, what x would I have to solve for so that it would, what's going into the input would be end up coming to be pi over 6. When I solve for that, I get negative pi over 12. So what that means is when I put negative pi over 12 into this equation, then I'm actually going to be taking the cosecant of pi over 6, which I know is 2, so I'll be able to say 3 times 2 is 6, minus 2 is 4. That's for the whole idea. So here's just a double check so you can see it. When I put in negative pi over 12, indeed, the input will end up being pi over 6, and I know the cosecant of pi over 6 is 2. So then you have 3 times 2 is 6, minus 2 is 4. So you'll end up plotting the point, negative pi over 12 and 4. So let's just go ahead and put that in there. So I'm here at something like, oops, sorry, forgot. I have to actually, let's see here, let me take that out. Might not be so accurate, but I'd be here, and this would be negative pi over 12, and up 4 would be this value here, okay? And just kind of clean that up a little. So, that's the basic thought process. And again, if you want to take another point, you want another value, you want to say, well, what would this one here be? Well, I would take this negative pi over 12 and add pi, and then I'd treat that and see how that works in the equation. All right, thank you so much for listening.